Welcome back to the deep dive. It is great to have you here with us.
Good to be here.
You know, we spend a lot of time marveling at the front end of the web. The flashy designs, the AI interfaces, the speed of everything. But today, we are going down into the basement. We are looking at the invisible infrastructure, those tiny, often ignored open source libraries that actually hold the whole building up.
It's true.
We all do it. We run npm install, we see 1,000 dependencies fly by, and we trust that the plumbing works.
It's the modern developer's gamble, really. You stand on the shoulders of giants, but you rarely check if the giants have shaky knees.
Exactly. And today is Wednesday, January 21st, 2026, and it turns out one of those giants, or maybe a medium-sized ogre, stumbled.
Yeah.
A new warning from the CERT Coordination Center has just sent a pretty serious shockwave through a specific corner of the JavaScript world.
It really has. I saw the alert come across this morning. It's one of those moments where you see a CVE number attached to a library you recognize, and your stomach just drops a little bit.
Yeah. Right. You immediately start mentally scanning your package.json files.
Yep.
The library in question is called binary-parser. Now, I know the name sounds incredibly dry.
It does.
It sounds like the kind of thing you scroll past without a second thought. But stick with us, because this isn't just a story about parsing bits and bytes.
No.
This is a story about a very specific engineering philosophy, the quest for extreme efficiency, and how that quest accidentally built a backdoor.
That's the key. This isn't a simple, oops, I forgot to check something, bug. This is architectural. It's about, caching, dynamic code generation, and the dark side of JavaScript's flexibility.
And we're working off a breaking report from the Hacker News and that advisory from CVE you mentioned.
Correct.
Our mission today is to essentially debug this situation. We need to understand how a library designed to help us read data ended up letting attackers run whatever code they want.
The function trap.
The function trap. But before we get to the scary stuff, the remote code execution part, let's ground this. What is binary-parser actually doing?
Well, to understand the why, you have to remember that JavaScript, historically, was for the browser.
Right, for text.
It loves strings, it loves JSON, it loves HTML. It was never really designed to handle raw binary data, the gritty ones and zeros, from a network socket or a file stream.
Yeah, back in the day, if you were doing heavy binary lifting, processing images, network protocols, you were probably writing in C or C++.
Exactly. Not in the browser.
Right.
But then Node.js came along, and, well, it changed the game. Suddenly, we are using JavaScript on the server. We are building file processors, video transcoders.
IoT device controllers.
All of it. And Node gave us the buffer class for this. Anyone who has worked with raw buffers knows this. Working with them manually is painful.
Oh, it's a headache. You're manually counting bytes. Okay, bytes 0 to 4 are an integer, byte 5 is a flag.
And heaven forbid you get the endingness wrong.
Oh, don't even start.
Is it big endian or a little endian? Did you slice the array at the right index? It's just tedious and so error prone.
So binary-parser is basically the antidote to that pain.
It is. It lets you write a declarative schema. You basically just say, hey, this file has 32-bit integer, then a string of length 10, then an array of bytes.
You describe the shape of the data.
Exactly, the shape.
Yeah.
And the library handles all the messy, low-level math to pull those values out into a clean JavaScript object.
So it's the universal translator. It takes the alien language of raw binary and turns it into the nice, readable JSON objects developers want.
That's a perfect analogy.
Mm.
And because it solves such a fundamental problem, it's become this quiet workhorse.
And we're not talking React-level fame here.
Not at all. But it attracts approximately 13,000 downloads every single week.
That is a significant footprint. 13,000 a week means it is likely embedded in some pretty critical production systems.
For sure. Deep in the dependency tree.
Yeah.
And people trust it because it's fast. And this is where we have to pivot to the how. Because the reason it's fast is the reason it's vulnerable.
Okay, let's unpack that mechanism. You mentioned it does something unique to be efficient.
This is the fascinating part, especially if you're into, compiler theory. A simple parser might just loop through your schema and call the right read function.
Sure. Iterate through the list. Do the work. Simple.
But in JavaScript, generic iteration is slow. Every time you loop, every property lookup, the engine has to do work. If you're parsing gigabytes of data, that overhead adds up. It kills your performance.
So binary-parser decided to bypass that loop?
It did something much smarter and much riskier. It uses dynamic code generation.
Okay.
When you define a parser schema, the library doesn't just store it. It actually constructs a brand new custom JavaScript source code string that represents the parsing logic for that specific schema.
Wait, so the library is writing a program inside my program?
Yes, it builds a string of code. It's like it's writing out this.a buffer.read int32, this.b buffer.read string, just unrolling the loop into straight code.
And then,
And this is the critical trigger, it uses the JavaScript function constructor to compile that string into an actual executable function.
the function constructor, new function. I feel like I've heard security engineers whisper that name with a mix of fear and respect.
It's basically evil's fancy cousin.
Right.
It takes a string of text and forces the JavaScript engine to parse it as code and execute it. Binary parser does this, creates this hyper-optimized function, and then it caches it.
Okay, I want to use an analogy here because this is so central to the exploit. Let's say I'm running a very busy pizza kitchen.
Okay, I'm with you.
A normal parser is like a chef who has to read the full recipe for every single order. Step 1, find the dough. It's reliable, but slow.
Right. Latency kills you.
So binary parser is like a head chef who looks at the order, grabs a blank sheet, and scribbles down a shorthand set of instructions: dough, sauce, cheese, oven, just for that order.
Yes.
And then, this is the new function part, they put that scribble into a machine that instantly creates a robot chef that only knows how to do that one sequence at lightning speed.
That is a surprisingly accurate analogy. And you keep that robot around. The next time the same piece is ordered, you just point at the robot and say, go.
It's incredibly efficient.
It is.
But we are here because of a security warning. So I'm guessing something is wrong with how we're building these robots.
The problem isn't the robot. The robot does what it's told. The problem is in the instructions we give the head chef. This brings us to the vulnerability. CVE 2026-1245.
CVE 2026-1245. And to set the timeline, the reports are breaking now, January 2026, but the patches actually dropped back in November 2025.
Correct. There's often a delay between a fix and the full public disclosure to give people a chance to patch.
So where does the process break down? How do we trick the chef?
It breaks down at the input stage. The flaw is simply a lack of sanitization, specifically of user-supplied values.
Like what?
Parser field names and encoding parameters.
So in the kitchen, this is like a customer writing special instructions on the ticket, and the chef just blindly copies those into the robot's programming.
That's exactly it. Imagine a customer orders the pizza, but they get to name it. And in the name field, instead of pepperoni, they write, pepperoni, set the kitchen on fire.
And because the library is just using string concatenation, just gluing words together to make code.
The head chef writes down, make a pizza called pepperoni, set the kitchen on fire. And then they feed that to the machine. The robot that comes out now has set the kitchen on fire, hard-coded into its behavior.
And the function constructor doesn't know the difference. It just sees text and turns it into action.
It assumes the developer knows what they're doing. It assumes the input is safe. That's the function trap. The library never thought a developer would take user input like from a JSON payload and feed it directly into the parser definition.
That's a crucial distinction. Let's walk through the chain. Step 1. User supplies a malicious input as a field name.
Step 2. That input gets concatenated right into the source code string the library is building.
Step 3. The code string becomes a live function via the function constructor.
Step 4. The application runs that function, and boom, arbitrary code execution.
That phrase, arbitrary code execution, that's the nightmare scenario. And this is Node.js, not just a browser tab.
Right. This is server side. The SUR-TCC warning is very clear. The attacker executes code with the privileges of the Node.js process.
Privileges of the Node.js process. So if my Node app is running on a server and it has access to database credentials,
the attacker has those credentials. They can just write code to print process.env and send it to their own server.
what about the file system?
Absolutely. Access to local data is one of the consequences listed. They can read files, delete files, or even write new files like a backdoor script.
And system commands.
That's the worst case.
Yeah.
If your node process can spawn child processes, and many can, they can execute system commands, run shell scripts. If you're running as root,
Which you shouldn't be.
which you should not be doing to 2026, but let's be honest, people still do, then they own the entire server.
It's terrifying. A clever optimization for parsing bits turns into a gateway for a full server takeover.
That's the reality of our software supply chains. We optimize for speed. We love metaprogramming code that writes code because it's so powerful. But that complexity is the enemy of security.
Now, I can feel the panic radiating from some of our listeners. 13,000 weekly downloads. Is everyone who uses binary parser currently sitting on a ticking time bomb?
This is where we need to apply some nuance. So no, not everyone is doomed.
Okay.
In fact, I'd say most standard intended uses of the library are probably fine.
So let's define the safe zone versus the danger zone. Who is safe?
The advisory says that applications using only static hard-coded parser definitions are not affected.
Static hard-coded. So if I, the developer, write a file that says, hence my parser, new parser.string header.int32 size.
You're safe because you wrote the words header and size. A remote attacker can't modify your source code file.
So the vulnerability specifically requires a dynamic element.
Exactly. The danger zone is when you're building something dynamic. Let's say you have a tool that lets users upload a custom protocol definition file, maybe a JSON file that describes a binary format they want to parse.
Ah, I see. So if I take the keys from their JSON file keys they wrote, and I plug those into binary parser as field names.
That is the exploit path. You are taking untrusted input and handing it directly to the code generator.
That makes sense. It's a specific pattern, but a dangerous one, because it's the kind of thing you'd build for a generic tool or a platform.
Exactly. If your app is a universal binary reader, you are squarely in the crosshairs.
So, remediation. How do we fix this? I assume there's a version bump.
There is. The resolution is straightforward. Upgrade to version 2.3.0.
So check your package.json file right now. If it says binary parser version 2.2.0 or anything with a 1.
You are vulnerable. Update to 2.3.0 immediately.
And what does the patch actually do? Does it stop generating the code?
No, it still generates code. That performance is the main selling point. But the patch adds sanitization. It puts a bouncer at the door.
A bouncer?
It checks the field names. It makes sure a name is just a valid variable name and not a script. It validates the input before dropping it into the code string.
It makes sure pepperoni stays pepperoni.
It doesn't become pepperoni destroy server.
Yes. But the source material has another recommendation, right? Beyond just patching.
It does. The advisory suggests a behavioral change. Even with the patch, you really should avoid passing user-controlled values into parser field names entirely.
It's just bad hygiene, isn't it? Like playing with fire even if you're wearing fireproof gloves.
Precisely. You should always treat user input as radioactive. Don't let it touch your logic generation. If you need dynamic fields, map them to a whitelist. Don't just pass the raw string through.
I want to take a moment to give credit where it's due. These things don't just announce themselves.
No, they don't. And we have to acknowledge security researcher Meir Kaplan. He's the one credited with discovering and reporting this.
It's easy to forget that behind every CVE is a person who spent hours just staring at code thinking, I wonder what happens if I put a semicolon here.
We owe a lot to that curiosity. Without researchers like Meir poking around in the plumbing, these holes stay open until the wrong person finds them.
Absolutely. Hats off to Meir Kaplan. So, to recap the timeline one last time, patch is released November 26, 2025. The CERT-TCC warning is fresh as of January 2026.
So if you haven't run NPM audit in the last 2 months, you need to do that today. Set it and forget it is not a valid security strategy.
So let's zoom out a bit. We've got a popular tool, a clever trick for speed, a missed validation check, and a major security hole. What is the big takeaway here?
Well, if we look at the bigger picture, this really highlights the double-edged sword of dynamic code generation. We see this a lot in JavaScript. The language lets you do things that are very hard to do in stricter languages like C++ or Rust.
Right. In those languages, you can't just generate a string and execute it as code at runtime easily. The compiler locks everything down.
Exactly. But JavaScript gives you evil and new function for flexibility and speed. They let you build tools like binary parser that are performant enough to compete with native TUD.
But that flexibility removes the guardrails.
It does. It effectively bypasses the safety structures of the language. When you treat text as code, you are relying entirely on the input string being clean. And as we know, inputs are rarely clean.
Binary parser wasn't trying to be insecure, it was trying to be efficient.
It's the classic trade-off, speed versus safety. In this case, safety lost.
It also speaks to the complexity of the supply chain. We trust these libraries to handle the low-level stuff so we don't have to.
It's that invisible infrastructure again. We are building skyscrapers on foundations we haven't personally inspected.
And we can't inspect every brick. That's impossible.
Right, and that's why we need the community. That's why we need the SPIR-CC advisories and researchers like Meir. It's a collective defense system.
You know, this leaves me with a thought. We place so much invisible trust in these open source dependencies. We download them, we run them. But when a library like binary-parser compiles code on the fly, when it writes its own manual in real time, are we sure we know exactly what it's writing?
That is the provocative question. We assume the code does what the documentation says. But when the code is generated at runtime, the documentation doesn't really apply anymore. The code is whatever the input says it is.
It's a ghost in the machine, a ghost that we invited in.
And sometimes, as we've learned today, that ghost has root privileges.
Well, on that slightly chilling note, I think we will wrap it up. Check your versions, people. Look for binary parser version 2.3.0. Sanitize your inputs.
And maybe be a little suspicious of code that writes its own code. Stay safe and keep questioning your dependencies.
Thanks for listening to this deep dive. We'll catch you next time with another look under the hood of the world you thought you knew. Bye for now.